In this lesson, we're going to use our accumulated knowledge on polynomials and polynomial functions to answer some real-life application questions. The weight of an ideal round-cut diamond can be modeled by W, this cubic function you see here, where W is the diamond's weight, which is measured in carats, and D is its diameter in millimeters. According to the model, what is the weight of a diamond with a diameter of 15 millimeters? So we're being asked to determine the weight when we're given that the diameter is 15 millimeters. So I really have two options here. The first would be to do direct substitution, where I take my function and I just substitute in 15 everywhere there was a D. And now I can just type this into my calculator. And when I do that, I get that W is approximately, I'm going to round 10.91. And I'm going to make sure I put a label on this. This is carats, how diamonds are measured. The alternate way to do this would be, of course, to do synthetic substitution, where the remainder, you would also get 10.91. But since it's decimals, direct substitution is definitely easier. In our second problem, it says, since 2010, the number in thousands of males, M, and females, F, attending institutes of higher education can be modeled by M equals, and you can see that cubic function, and F equals a second cubic function, where T is the number of years since 2010. Write a model for the total number of people attending institutes of high learning. So we need something that represents the total people, so your males and your females combined. I'm going to say let A, my brain is thinking my attendance, be equal to the males plus the females. Therefore, what am I doing is I'm adding these two functions together. So I'm writing my two functions. I'm going to put a plus sign in between the two, and I'm saying that A is equal to their sum. Now, all I need to do to add polynomials together would be to combine like terms. So I see two cubic terms. This would be 0.281 t cubed. Remember, when you add, your variables on your exponents do not change. Look for my squared terms. I have negative 4.8 minus 12 t squared would be negative 16.8 t squared. Going to go to my my linear terms, which would be 110t plus 350t would be a positive 460t. And lastly, my constants, I have 5,000 plus 3,600 would be 8,600. I check to see if this has any more like terms. I don't see any. It's in standard form. So here is the cubic model that represents the grand total of males and females together attending this higher institution. Number 3 is an interesting question. It says, what's the value of k such that x minus 5 is a factor of x cubed minus x squared plus kx minus 30. So this has got this extra k in here, and that's what we're trying to figure out, what's the value. And what are we told? We're told that x minus 5 is a factor. Well, you know that if x minus 5 is a factor, that means it has a remainder that's equal to 0. It goes into it evenly. So let's kind of fill in what we know and see if we can use some logical reasoning. So 1, negative 1, then I have a k, and then negative 30. And I know that my remainder has to be 0. What else do I know? Well, x minus 5 is a factor. Remember that the corresponding 0 goes here on the outside. And now I am going to do my synthetic with what I know. So bring down my 1. I multiply to get 5, add to get 4. 5 times 4 is 20. Now, if I would go to add at this point, I'm going to have k plus 20. So I want to just see if we can do this, finish this by logical reasoning. So if I have 0 here, what plus negative 30 would have given me 0? Well, it would have to be the opposite. So I know this value has to be 30. And then if I back up to get this value, Remember, it's obtained by saying 5 times something is equal to 30. Well, what is that something? It would have to be 6. Okay, so one more thought process here is going to get us the value of k. Normally, I would add k plus 20 to get 6. Well, what would k have to be if k plus 20 is equal to 6? That would be negative 14 would be my unknown value. For those of you who prefer more algebraic reasoning, I've set it up a second time to just kind of show you how else you can think this through. So you could, if you just say you do your synthetic, you'd get 5. Excuse me, no you wouldn't. You'd get 1, then you'd multiply to get 5, add to get 4, multiply to get 20, and right here you'd have k plus 20. And then you do 5 times k plus 20, and that would be 5k plus, zoom in here, 5k plus 100. And then we would add vertically, negative 30 plus 5k plus 100 would be 5k plus 70. But I know that that has to equal 0 because that's the remainder. So if you just take this 5k plus 70 and solve it, then you'll also get the value of k. So kind of another way to think this through. Oops, that's a sloppy k. 5k equals negative 70, divide both sides by 5, and I get k equals negative 14. So it's kind of latch on to whichever way you like better. I'm guessing most of you are going to like this logical reasoning way, but you could completely do synthetic as well. I'm going to temporarily bypass number 4. I'll record this on a separate video for you because it's a little more challenging. Let's jump right to 5. A factory needs a box that has a volume of 1,728 cubic inches. The width should be 4 inches less than the height, and the length should be 6 inches greater than the height. What will the dimensions of the box be with those specifications? So I've sketched a picture of a box because it's going to help me figure out my known and unknown information. So I know that the volume is equal to 1,728 cubic inches. I also know that volume is equal to length times width times height. So I'm just putting some information down. Now, what do I know? The width should be 4 inches less than the height, and the length should be 6 inches greater than the height. So I think, which one do I know absolutely nothing about? Well, that's the height. So that's going to be my variable. I'm going to call that h. And I'm going to go from here. The width should be 4 inches less than the height. So I'm going to say my width, this one, will be h minus 4 because it's 4 less than the height. And now my length should be 6 inches greater than the height. So it'd be h plus 6. So here are my 3 dimensions. So I'm going to use this idea of volume. So the volume, which is 1,728 inches, is equal to these 3 sides multiplied together. Does the order matter? No, because if I just kind of rotate a box, what I called the length could suddenly be the height. So just multiply the 3 together. Now let's use our knowledge of solving polynomials. So I'm going to multiply my 2 binomials together, the h minus 4 and the h plus 6, to get h squared plus 6h minus 4h minus 24. I'm going to combine my like terms in the middle to get h squared plus 2h minus 24. And now I'm just going to distribute this h. Gives me h cubed plus 2h squared minus 24h. And I'm also going to subtract now the 1728 from both sides. So my function will be 0 equals h cubed plus 2h squared. I really should say my equation, not my function, because it's in one variable, minus 1,728. So now I need to solve this. So how do I solve a cubic equation? Well, I need to find one of its zeros. So you could try grouping this as a 2 and a 2 and do a factoring method to solve. Or probably the easiest thing is to put this in your graphing calculator and look at the picture and see if you can identify a 0. So when I graph this, I can see that it crosses at 12, and it almost looks like it's a vertical line, but it's not. I'd have to zoom way out to see this curve. So that tells me that the only 0 of this cubic that I can see is 12, so the other two must be complex. I don't see it crossing the axis. So that means h is 12. How do I get my other sides? Well, I do 12 minus 4. I just plug it in right here. This side would be 8 inches. And this side over here would be 12 plus 6 will be 18 inches. So my length times my width times my height would be 18 inches by 8 inches by 12 inches for the dimensions.